Okay, so hello. Today we'll be learning about hybridization. So basically, hybridization happens between like the hybrid orbital. You could figure out the hybrid orbital by using or knowing the amount of electron domains inside of a molecule or a substance. For example, like let's say take nitrogen N2. For example, you have to first write the Lewis structure of N2, which would look like this. Right now, how many electron domains can you depict from this nitrogen atom? This nitrogen atom would have two electron domains, one here and one here, right? So it would have, say, an sp hybridization orbital, right? So when it has an sp hybridization orbital, so an sp hybridization orbital consists of two sp orbitals, right? Two sp orbitals, right? And two p orbitals, and two p orbitals remaining, right? Because okay, so in this molecular orbital model, you have two sp orbitals and two p orbitals, right? Now to exactly figure out how this molecular orbital is shaped like, first of all, you have to recognize the difference between a sigma and a pi bond, right? Sigma and pi bond. Now usually in any type of molecule, you always have a sigma bond, right, between two sp3 orbitals or sp2 orbitals, right? Because a sigma bond consists of just like a single bond consists of just one singular bond between a molecule. So let's say here, one single bond between any molecule. So in any type of bond, you will always have a sigma bond. And then when you have a double bond, the bond associated with the second one would be a pi bond. So the difference between a sigma and a pi bond is that a sigma bond, the two bonds overlap each other like this. The two sp orbitals overlap to form a sigma bond. Now this is just review. You should know most of this already. To form a sigma bond, and a pi bond consists of two pi orbitals that overlap at two different parts, at two different cross-sectional areas or so, right? So the orbital probability or electron density is distributed extended to the two orbitals like this. So you would have an electron cloud, and of course this is in 3 dimensions inside a p orbital, a pi orbital or so, a pi bond. So you know what an sp orbital looks like, and since it has 2 electron domains, you know it's going to be an sp orbital. If it has 3 electron domains, it's going to be sp2, and 4 electron domains, which is a tetrahedral, it's going to be sp3. So knowing the gist of this, you could, for writing out, sort of just drawing what this molecular orbital will look like, you could first write this nitrogen atom, let's say in the center, right here, and there's two sp orbitals sticking out. One would have just the 2 electron domains here, and the other one is bonded to the other nitrogen atom, the other sp orbital. The other sp orbital is bonded with this other nitrogen atom right here, and they overlap with this cross-sectional area, right? And then you have this other electron domain associated with this nitrogen as well. These 2 electron domains, and you have 2 pi bonds. One is in the y-axis and the other one would be in the z-axis. So you have one pi bond between the two nitrogen atoms in the y-axis, so here and here. And since it's a triple bond, you have another one in the z-axis, and they would bond together. So you basically get the gist of how these molecular orbitals work. So now suppose you have like a trigonal bipyramidal form, or because you have, let's say, 5 electron domains, so it takes on hybridization of dsp3. So you could look at the hybridization of this. So it hybridizes, uses this D subshell, this MT3 D subshell to hybridize.